Hey guys, today we're going to just look at section 5.1 part 2, which is simplifying trig expressions. So expressions means it's not an equation because it does not have an equal sign, so we are just trying to simplify the expression that we have. So we are going to be using our trig identities, the top right there that we used in our previous class. So by simplifying trig expressions, we have to look and see what we are given, and then use the identities as best as we can to simplify the expression into the least number of trig functions. So number one, sine of theta times secant of theta. So I always suggest writing most things in terms of sine and cosine unless the two functions relate on their own. So in this case, sine of theta and secant. Secant is not the reciprocal of sine. Secant is the reciprocal identity to cosine. So let's rewrite secant of theta as 1 over cosine theta. So now we have sine theta times 1 over cosine theta. I'm multiplying these, sine of theta over 1 if you'd like. This multiplied out would be sine theta over cosine theta. Pause and think, is there any trig function that represents sine theta over cosine theta? If you said tangent, you are correct. So this is tangent of theta. So that expression simplifies to tangent of theta. So you can use the reciprocal identities to help you rewrite everything in terms of sine and cosine. That works out really well when you have a product. Number two, when you have two terms. We have two terms separated by this subtraction sign here. Always look and see if anything could be factored. Is there anything that's in both terms? In this case, sine x is in both. So if you factored out sine x, you would have cosine squared x minus 1, because you were taking this whole piece of the term out, but there is a subtraction sign in front of it. Cosine squared x minus 1. Whenever you see a square, your Pythagorean identity should stand out to you. Cosine squared minus 1. That isn't a specific identity, meaning it's not the exact same written, but we can rewrite our identities by using the properties of equality. So over here, sine squared, and since our expression down here is in terms of x's, I'm just going to rewrite our identities in terms of x's. Sine squared plus cosine squared x equals 1. Cosine squared x minus 1. I need to subtract 1 on both sides. So sine squared x plus cosine squared x minus 1 equals 0. I want this to be isolated, so I need to subtract sine squared to the right. So cosine squared x minus 1 is in fact equal to negative sine squared x. So this, in parentheses, using the Pythagorean identity, can simplify to negative sine squared x. Now, we have, my pen does not want to write s's today. So now we have sine of x times negative sine squared x. Sine times sine squared is sine cubed. And don't forget the negative sign. So this simplifies to negative sine cubed of x. Likewise, last example. Let me see if I can do this without messing everything up. All right, so, oops. I'd like you to try this one on your own, number 3. Cosine squared x cosecant x minus cosecant x. If you need to rewind and look and see how we did number 2, do that. And come back and try solving this one. All right. Cosecant x is in both, so let's factor out cosecant x. Here's our cosine squared x minus 1. We did this in the previous example. That equals negative sine squared x. And we don't have the exact thing here, so CSCX. So cosecant and negative sine squared x. We have to get cosecant and sine to be the same, so let's use reciprocal identities and change cosecant in terms of what its relationship is with sine. So 1 over sine. So 1 over sine x times negative sine squared x. You need to put it over 1 just so you can see that. Sine squared, so we have sine times sine, and we have one sine on the bottom here. So one of these is going to cancel with one of those. So we are going to be left with negative sine to the first, which we just write sine x. Final answer. All right, this was just an introduction. We're going to work on this more next class, but I just thought it'd be best for you guys to see a few examples here. Write down any questions you have, and I will see you guys next class. Hope you have a great rest of your day. Thanks, guys.